Imagine you're like 100 feet underwater.
Right.
And it is just pitch, total darkness. You're holding a welding torch, and it's currently generating hundreds of amps of electricity.
Which is just a terrifying thought right out of the gate.
Oh, completely.
Right.
The water around you is freezing cold. You can't even see your own hands, let alone the massive, steel structure you're supposed to be repairing.
All right, because of the zero visibility.
Exactly.
Yeah.
And, that just one wrong move, like a slight miscalculation in your gas mixture or a sudden change in water pressure, and either the electrical current or the ocean itself is just going to kill you instantly.
Yeah, it's an environment that absolutely does not care about your intentions. I mean, it doesn't care about your background or your theories. It only cares about physics.
Yeah.
It's a space where the margin for error isn't just small, it is literally zero.
Right. So you have to ask yourself, what kind of mind actually survives that environment day in and day out? And I guess more importantly, what happens when that exact same mind, a mind wired by life or death physics in the darkest parts of the ocean, decides to, pivot and start building artificial intelligence architecture?
It's just such a wild collision of worlds, honestly. That's what we're looking at today. We are examining a life that completely breaks the standard categorization machine of modern careers.
It really does. So welcome to today's deep dive. We are unpacking a truly extraordinary CV sourced from a specific website, Baires.info, that's belonging to Jose Baires, or JB. And just to set the tone for this, there's a quote prominently featured right there on his site by the legendary oceanographer Jacques Cousteau.
Oh, I love that quote.
Yeah, it says, when one man, for whatever reason, has the opportunity to lead an extraordinary life, he has no right to keep it to himself.
And, usually if you saw a sweeping, cinematic quote like that on a standard corporate profile, you'd probably roll your eyes.
Oh, 100%. You'd think, okay, buddy.
Right, like it feels like hyperbole.
Yeah.
But when you actually start parsing through the raw data of what this person has achieved, you realize it is a literal objective description of the document. I mean, we are looking at a masterclass in extreme information retrieval across completely incompatible realms of human knowledge.
Exactly. The sheer breadth of the source material we are looking at today is staggering. It spans extreme underwater industrial diving, marine biology, underwater archaeology, volcanology, theology, and then completely out of left field cutting edge AI engineering.
It's just so much to take in.
It is. And if you are listening to this right now and you feel like your own career path is a bit scattered, well, wait until you hear how this guy connects the dots.
Yeah, because I think most careers are strictly linear. You start at point A, you move to point B within the same vertical, you get promoted.
Stay in your lane.
Exactly. But this source material reveals a radial approach to life, like expanding outward from a center point into seemingly disconnected fields that actually share a really deeply hidden mechanical thread.
Okay, let's unpack this, because before we get to the artificial neural networks or mapping submerged Maya ruins or tracking humpback whales, we have to understand the physical reality this person operated in. We have to look at the forged foundation.
The industrial stuff.
Right. The source material outlines his background as a commercial diver. But to be clear, this isn't like leading tourist scuba groups looking at parrotfish in the Caribbean.
Oh, no, not even close.
Right. He specialized in hydroelectrical dams and piers in El Salvador, and it lists his work doing tuna fleet boat reparations and underwater welding for the Spanish Calvo group.
I just have to stop you right here because I need to understand the actual mechanics of this. How does someone even learn to weld underwater?
It's wild, isn't it?
It sounds impossible. You have hundreds of amps of direct electrical current and you're submerged in salt water, which is a fantastic conductor of electricity. How are you not instantly electrocuted the second you strike an arc? Well, it is a brilliantly hostile engineering challenge for sure. What we're talking about here is called wet welding, specifically shielded metal arc welding, or SMAW.
Okay.
So the diver uses a specialized waterproof electrode. And when they strike the arc against the metal hull of the ship, the heat instantly vaporizes the water immediately surrounding the weld, which creates this tiny, localized gaseous bubble.
So you're basically creating a miniature atmosphere of steam and gas to weld inside of.
Exactly. The flux coating on the electrode burns, and it releases gases that stabilize this bubble that shields the weld pool from the surrounding water. Because if that water rushed in, it would quench the molten metal way too quickly.
And what happens if it quenches too quickly?
It causes the metal to become extremely brittle. brittle. It's a phenomenon known in metallurgy as hydrogen embrittlement. The weld would just snap under pressure.
Wow. Okay, but to my point about the electrocution part, how does the diver not fry?
Right, so the diver is literally part of the electrical circuit. They have to rely on strict, heavy-duty insulation, thick rubber gloves, and a surface team operating what's called a knife switch.
A knife switch, like a giant lever.
Yeah, pretty much. The torch is only hot when the diver explicitly calls over the comms for the current to be turned on. So if the diver's communication fails, or if they accidentally position themselves between the ground and the electrode,
Oh, man.
yeah, the current travels directly through them. It's incredibly dangerous.
That is just terrifying. And he's doing this on the hulls of massive commercial tuna fleets for the Calvo Group. I mean, I am picturing these gigantic floating factories bobbing around in the open ocean.
Massive vessels.
You're dealing with the surge of the sea, the immense weight of the vessel, and you're trying to maintain, what, a fraction of an inch arc length in total darkness to lay down a structurally sound weld.
Yes, and that is just the tuna fleets. The CV also notes his work on hydroelectrical dams and piers in El Salvador. And if you talk to any commercial diver, hydro dams are widely considered one of the most uniquely terrifying environments on the planet.
Really? Why is a dam worse than the open ocean? I mean, at least a dam is stationary, right? It's not bobbing up and down.
It is stationary, sure, but it's fundamentally a machine designed to control the massive kinetic energy of water. So when a diver is working on a dam, like inspecting grates, repairing sluice gates, clearing debris, they're dealing with a physical phenomenon called differential pressure, or what the industry calls delta P.
Delta P. Okay, I've heard of this, but can you explain the actual physics of it?
Yeah.
Because it sounds awful.
It is. Think of a massive wall of water held back by a concrete dam. The pressure at the bottom is just immense. If there is even a small hole, a crack, or a partially open valve leading to a lower pressure area on the other side of that dam, the water forces its way through that opening.
Because it wants to equalize.
Exactly. The physics equation is simple but brutal. It's force equals pressure multiplied by area. And because water is non-compressible, it doesn't just flow through the hole nicely, it violently seeks equilibrium.
Okay, so if you're swimming near it,
If a diver gets too close to that opening, they aren't just pulled against it. They are sealed against it by thousands of pounds of pressure.
meaning they literally cannot move, they are pinned by the water itself.
Pinned and often crushed. A human being cannot physically pull themselves off a severe delta P suction. I mean, even a small 6-inch pipe with a significant pressure differential can generate thousands of pounds of force.
Good Lord.
And the worst part, it's invisible. It makes no sound underwater, and it is instantly lethal.
Wow. Which completely reframes the next block of credentials on this CV. Because alongside these heavy industrial jobs, there's this really heavy emphasis on safety certifications.
Yes, very prominent.
He is listed as an OSHA Academy instructor, an EFR, which is Emergency First Response CPR instructor, and a PADI Master scuba diver trainer. And you know, if you just glance at this, you might think, oh, he took some first aid courses. But in the context of delta P and hyperbaric wet welding, this isn't resume padding.
No, it is the absolute core of his operational psychology. Being a safety instructor across OSHA standards, CPR, and PADI is a foundational framework for surviving extreme chaos.
Right.
When you are underwater welding, you're running a constant simultaneous calculation of like your gas supply, your depth, your nitrogen absorption limits, the electrical hazards, and the structural integrity of the steel. You have to build a deterministic closed-loop system of verifiable facts just to stay alive.
Deterministic. I love that word here. You mean a system where cause and effect are absolute and mathematically predictable, no guesswork.
Yes. In that environment, you cannot rely on probability. You cannot guess. You need to know exactly what is happening with absolute factual certainty.
Right, because the consequences are so final.
Exactly. If you guess your depth incorrectly, you suffer decompression sickness. Literally bubbles of nitrogen forming in your bloodstream. If you guess the state of the electrical current, you are electrocuted. You just do not have the luxury of assumptions.
So we had this foundation of intense industrial grit, a mind wired by the unforgiving physics of the deep ocean and dams. But this is where the CV pivots in a way that I find just fascinating.
It really takes a turn.
He didn't stay locked in the industrial side of the ocean. He took this hyper-precise, deterministic mindset and began applying it to natural ecosystems.
This is where we see the transition from manipulating the environment to decoding it. The source material lists 3 major ecological projects, starting with marine biology, specifically humpback whale research.
Right. The sources indicate he was responsible for elaborating the first photo ID catalog in El Salvador's Los Cabanos Marine Protected Area, or MPA. Okay, break this down for me. What exactly goes into a photo ID catalog for whales, and why is it important? Because, honestly, it sounds like you're just taking pictures of animals on a boat.
It's much more rigorous than that, I promise. What he was doing was essentially building a biometric database.
A biometric database?
Yeah.
Like facial recognition for whales?
Sort of. Humpback whales have distinct, highly unique markings on the ventral side, so the underside of their tail flukes. They have distinct trailing edges, scarring patterns, and black and white pigmentation that are as unique to an individual whale as a fingerprint is to a human.
You're cataloging fingerprints for 40-ton mammals.
Precisely. But consider the operational difficulty of actually doing that. You are on a small vessel in the open ocean. You have to track these massive creatures, understand their behavioral patterns, and anticipate the exact moment they initiate a deep dive.
Because that's when a tail comes up.
Right, that's when they raise their fluke out of the water. You have a window of just a few seconds to capture a high-resolution, perfectly angled photograph. If the angle is off, the data is useless.
And the fact that he was elaborating the first catalog in the Los Cabanos MPA means there was no baseline data before this. He is establishing the foundational data set for that entire region.
And that data set is critical for global marine biology because when a researcher in, say, Antarctica or California photographs a whale, they can cross-reference it against the Los Cabanos catalog.
Oh, wow. So they can see where that specific whale has traveled.
Exactly. This is how scientists track global migration routes, measure population health, and understand breeding cycles. It is rigorous observational data extraction. He is recognizing complex visual patterns in a really chaotic environment.
That pattern recognition is key. We're going to see that come back in a huge way when we get to the AI section. But while he is in the Los Cabanos MPA identifying whales, the CV notes he's also doing something much more dangerous. He was doing conservation work, specifically retrieving abandoned and discarded ghost fishing nets.
This is a perfect synthesis of his skills. Ghost nets are one of the most insidious threats to marine ecosystems.
Yeah, they're awful.
They really are. These are massive, commercial-scale synthetic nets that have been lost, cut loose, or just abandoned by fishing vessels. Because they're made of durable polymers like nylon, they don't degrade.
They just drift forever.
Right. They just drift through the ocean currents, endlessly catching, drowning, and crushing marine life sea turtles, sharks, dolphins, and entire reef systems.
Hence the name ghost nets. Yeah. They're phantom traps that just never stop hunting. But mechanically, how do you actually get them out of the ocean? I mean, you can't just swim up and pull them onto a boat, right? They must weigh a ton.
Oh, attempting to do that is incredibly dangerous. These nets often weigh thousands of pounds when they're waterlogged and entangled with coral, debris, and dead marine life.
Wow.
They are massive amorphous structures floating in the water column or draped over reefs. If a diver gets caught in one, if a single thread wraps around a fin buckle or a tank valve, they can be trapped.
So how does a diver extract a multi-ton net without rocketing to the surface or getting crushed?
It requires deep industrial expertise. You have to use heavy lift salvage bags. So a diver swims down, carefully attaches these heavy-duty canvas balloons to structural points on the net, and then uses compressed air from their tank to inflate the bags.
Oh, okay, so it floats them up.
Right, but it requires precise calculations based on Boyle's law. As the bag rises, the ambient water pressure decreases, which causes the air inside the bag to expand.
Oh, so it gets more buoyant as it goes up.
Exponentially more buoyant. If you put too much air in at the bottom, the lift bag accelerates violently toward the surface. It can rip the net, it can drag the diver up with it, causing decompression sickness, or it can reach the surface, vent the air, and sink right back down on top of you.
This is exactly what we were talking about earlier. He is directly leveraging his commercial diving and safety expertise. He is taking the heavy industrial skills he learned working on hydro dams and tuna fleets and applying them to ecological rescue.
Exactly.
He's calculating physics, managing risk, and executing heavy salvage in a fragile ecosystem.
He understands the mechanics of the threat because he worked inside the heavy maritime industry. He is using the machinery of the ocean's industrialization to dismantle its mistakes.
That's a great way to put it. And from the massive scale of whales and tons of synthetic ghost nets, the CV suddenly zooms in on a microscopic level. It lists bioluminescence research, specifically studying ostracods in Roatan, Honduras.
This is such a fascinating contrast. Have you ever seen an ostracod?
I don't even know what that is, honestly.
They're tiny seed-like crustaceans, often only a millimeter or two in size, and some species possess this extraordinary evolutionary ability to produce light through a chemical reaction. In places like Roatan, Honduras, if you dive at night, you can observe these incredible synchronized bursts of bioluminescence in the water column.
Wait, how does a microscopic crustacean physically generate light without burning itself up? Like, what is the actual biological mechanism there?
It's a highly efficient chemical reaction known as chemiluminescence. The ostracod secretes two chemicals, a light-emitting molecule called luciferin and an enzyme called luciferase. When these two chemicals mix in the presence of oxygen in the seawater, it triggers an oxidation reaction that releases energy in the form of a photon, which is visible light, and it's what we call cold light.
Meaning it doesn't get hot.
Right. Nearly 100% of the energy is released as light, with almost no heat generated, which is why it doesn't harm the organism.
That is incredible. And what do they use it for? Mating.
Mostly, yes. Depending on the species, it's used for complex mating displays. The males leave a precise, coded trail of light pulses in the water to attract females. Some also use it as a defense mechanism, like a sudden burst of light to blind or distract a predator.
A microscopic flashbang.
Exactly. But think about the observational environment here for a researcher. To study this, you are diving at night in pitch black water. You have absolutely no visual reference points. You are suspended in the water column, relying entirely on your instruments for depth and buoyancy control, while your brain tries to process these tiny, fleeting pulses of chemical light.
It requires extreme spatial awareness. Because if you lose track of up and down, you're in trouble. But whether he's in the murky water of a hydroelectrical dam looking for a structural flaw, or tracking the biometric pattern of a whale fluke, or documenting microscopic chemical light in pitch black water, his core function remains exactly the same.
Yes, he is an extractor of hidden information.
He is isolating the signal from the noise in extreme environments.
Which is the perfect transition, really.
It is. Because if you can track the biological signal of a whale across an ocean, and you can map the chemical signal of a microscopic crustacean, it raises an entirely different question. Can you track the signal of a lost human civilization?
And this brings us to his work in underwater archaeology. The source material explicitly highlights his work in Lake Gija.
Right. It states that in Lake Gija, JB designed and elaborated a bathymetric chart. And this mapping directly resulted in the finding of a submerged Maya structure, which ended up supporting a theory by a Professor Marlon Escamilla.
It's just an amazing find.
Okay, I need a deep dive on bathymetry here, because to a layperson, charting a lake sounds like, I don't know, drawing a rough outline of the shoreline on a piece of graph paper. What does it actually mean to elaborate a bathymetric chart?
So, bathymetry is the underwater equivalent of topography. You are mapping the precise three-dimensional depth and terrain of the underwater landscape. And to do this at a professional archaeological level, you aren't just dropping a weighted line into the water, you are using multi-beam sonar systems.
So you're bouncing sound waves off the bottom.
Exactly. The sonar transducer on the boat emits this fan-shaped acoustic pulse downwards. The sound waves hit the lake bed and bounce back to a receiver. By calculating the exact time it takes for the echo to return, which is called the time of flight, you can calculate the depth.
Sounds pretty straightforward.
It sounds straightforward, but it's incredibly computationally intensive because you have to account for the speed of sound in water.
Which changes, right?
Constantly. It's roughly 1,500 meters per second, but that speed changes based on the water's temperature, its salinity, and the depth pressure.
So if you have, like, a thermocline, a layer of suddenly colder water in the lake, it actually bends the sound wave and distorts your data.
Yes, it causes refraction. So to elaborate a highly accurate chart, you have to constantly profile the water column's sound velocity and calibrate your sonar data against it in real time. You are basically creating a massive, high-dimensional point cloud of data that represents the lake floor.
And what does a submerged Maya structure actually look like in a point cloud of sonar data? I imagine it doesn't look like a perfect Chichen Itza pyramid on a computer screen.
No, usually it looks like an anomaly. A natural lake bed has a certain geological randomness to it, like sloping mud, scattered rocks, uneven contours.
Chaos, basically.
Right, geological chaos. But when you are analyzing processed bathymetric data and you suddenly see rigid geometry straight lines, unnatural elevations, perfect right angles, or a plateau that just doesn't fit the natural weathering patterns, you are looking at something anthropogenic, something made by humans.
Which, in this case, was the submerged Maya structure that Professor Marlon Escamilla had theorized existed. And this highlights such an interesting dynamic in academia. A professor like Escamilla can analyze historical texts, folklore, and adjacent land-based archaeological sites and formulate a brilliant theory. But a theory remains a theory until someone actually finds the physical structure.
And academics are rarely the ones equipped to execute extreme underwater operations.
Yeah, professors aren't usually commercial divers.
Usually not. You need a bridge between the theoretical academic world and the unforgiving physical reality. JB possessed both the extreme physical capability to operate safely in murky, difficult waters and the rigorous technical mindset to collect pristine, unimpeachable sonar data. He pulled the truth out of the lake bed.
Pulled the truth out of the lake bed. That's good. But if Lake Geija wasn't extreme enough, the CV immediately hits us with volcanology. Yeah, just a casual Tuesday. It details his research in the Ilopango caldera, exploring underwater geothermal vents in collaboration with two more academics, Professors Ivan Siniapuchol and Carlos Pollinger. And I read that and immediately thought, what does an underwater volcano actually look like to a diver? Why would you ever willingly swim into one?
The Ilopango caldera in El Salvador is a massive, active volcanic crater lake. Diving into underwater geothermal vents is an entirely different magnitude of hazard compared to normal diving. It is the literal intersection of extreme geology and extreme fluid dynamics.
Because the water is literally boiling.
It can be, near the vents. The geothermal vents are fissures in the Earth's crust releasing superheated water and volatile volcanic gases like hydrogen sulfide, carbon dioxide, sulfur dioxide.
Toxic stuff.
Highly toxic. And when this superheated vent fluid hits the cooler lake water, it creates intense localized temperature gradients. But temperature is just one variable. The water chemistry around these vents is highly toxic and extremely acidic.
Wait, how does that acidity affect the scuba gear? I mean, life support equipment is made of rubber, plastic, and metal. Doesn't it melt?
That is exactly the risk. Highly acidic water can degrade O-rings, corrode regulator components, and cause catastrophic equipment failure while you're breathing from it.
Oh my God.
Furthermore, the visibility can drop to absolute zero instantly due to particulate matter precipitating out of the vent fluid, or just massive columns of gas bubbles blinding you.
So you're blind, in boiling acid water, relying on rubber O-rings.
Yes. Diving in those conditions to collect scientific data like taking precise water samples at specific depths, measuring thermal outputs, mapping the vent structures, it requires blending peak physical diving prowess with strict, methodical scientific discipline.
It is the ultimate test of the deterministic mindset we talked about with the hydro dams. In an underwater geothermal vent, the margin for error isn't zero. It's practically negative. If you miscalculate the pH level, your breathing regulator fails. If you ignore a temperature gradient, you suffer severe thermal injury. You're relying on a closed loop of absolute truths. Your training, your gas mixture, your thermal protection. If any of those variables are compromised, the environment just consumes you.
He is acting as the physical extraction mechanism for Professors Siniapuchol and Pollinger. He goes into the most chaotic, lethal environments on the planet, establishes a deterministic loop of safety, and extracts pure scientific truth.
Which perfectly sets the stage for the most shocking pivot in this entire CV, because we have spent this entire time talking about physical data retrieval, manipulating massive steel structures, charting the biology of whales and microscopic crustaceans, using sound waves to map ancient ruins, and probing active volcanoes. It is data retrieval in the wettest, heaviest, most dangerous sense possible.
It's all incredibly tangible.
Right, tangible. But then the CV completely shifts mediums.
We transition from the physical ocean to the digital ocean.
Exactly. We are looking at a guy who welds ships and dives into volcanoes. And the next major item on the Baires.info CV is a Google AI Professional Certificate.
Talk about a pivot.
And not just a certificate. He published a paper on Zenodo, version V1, published July 30, 2026. And the title of the paper is Paix AI, a deterministic closed-loop architecture for zero hallucination data retrieval in large language models.
At first glance, it feels like a total non sequitur, right? Oh, what does a commercial diver have to do with artificial intelligence?
Nothing, you would think.
But when you analyze the vocabulary and the architecture of what he's proposing in this paper, it is the exact same skill set applied to a different medium.
Let's get into the mechanics of this, because this is where my mind was completely blown, but I also have some major doubts about it. The paper targets the biggest flaw in large language models, which is hallucination.
The bane of generative AI.
Right. We all know the headache of LLM hallucinations. You ask an AI to write a legal brief, and it invents a court case that never existed, complete with fake citations.
Right. And to understand why that happens, you have to understand the underlying architecture of an LLM. They are built on transformer architectures that use attention mechanisms to weigh the relevance of different words or tokens in a sequence. Fundamentally, an LLM is a probabilistic engine.
Okay, meaning it plays the odds.
Exactly. It doesn't know facts in a database sense. When it generates text, it uses a mathematical function called a softmax layer to predict the most statistically probable next token based on its vast training data. It is literally guessing what word should come next.
Yeah, as we established earlier, in JB's world, guessing gets you killed.
Yeah.
If you guess your oxygen mixture at 100 feet down, you die. So here is my pushback on this paper. If the entire foundation of a neural network is that it is a probabilistic guesser, a stochastic parrot, as they call it, how on earth can you force a closed loop on it?
It's a great question.
The title of his paper calls for a deterministic architecture. Isn't a deterministic LLM an oxymoron? How do you force a system built on probability to act with absolute certainty?
That is the brilliant crux of the PAX AI architecture. You are entirely correct that the core LLM is probabilistic. You cannot change the fundamental math of the transformer.
Right.
So what do? You build a containment system around it. You build a closed loop.
Like a rebreather in extreme diving.
Precisely. Think about it. In deep water diving, a closed-circuit rebreather doesn't rely on the open ocean for air. It recycles the diver's exhaled breath, uses chemical scrubbers to remove the toxic carbon dioxide, and mechanically injects exact calculated amounts of oxygen back into the loop.
It creates a microenvironment.
Yes. It isolates the diver from the chaos of the environment. In AI, a closed-loop architecture for zero hallucination utilizes advanced forms of what we call retrieval augmented generation, or RAG, but taken to an extreme deterministic level.
So how does the closed loop actually govern the AI token generation in practice?
Instead of letting the LLM rely on its internal probabilistic weights to answer a question, the architecture intercepts the user's query. It searches a strictly curated, high-dimensional vector database of absolute facts. It retrieves the exact factual data, and then it forces the LLM to only use that retrieved data to formulate the answer.
Oh, I see. So it handcuts the AI to the database.
Yes. Furthermore, a deterministic loop sets the temperature parameter of the LLM to 0, stripping away its creative variance, and it institutes strict validation loops, essentially algorithmic safety checks, that constantly verify the generated output against the ground truth data before the user ever sees it.
It's an algorithmic safety valve. If the output deviates from the retrieved data, the system scraps it. It refuses to guess.
Exactly. Just like how a commercial diver relies on strict OSHA safety protocols, or how a diver in the Ilopango caldera relies on exact gas mixtures. JB recognized that the digital sea of information is just as chaotic, murky, and dangerous as a volcanic crater lake.
That's such a cool analogy.
If you let an AI wander around in that high-dimensional space without a tether, it will hallucinate. It will get lost in the dark.
It is such a stark contrast to the standard Silicon Valley mindset. I mean, the tech industry was built on the mantra of move fast and break things. Software engineers are totally comfortable shipping beta products with bugs, because in the standard app, a bug just means the app crashes and you restart your phone.
Right. But when you apply that move fast and break things philosophy to an AI that might soon be managing power grids, diagnosing patients in hospitals, or writing binding legal contracts, a bug or a hallucination becomes catastrophic.
And that is why a commercial diver might be the exact right person to solve AI hallucinations. Silicon Valley engineers haven't spent their lives in environments where a single broken thing means instantaneous death.
JB has.
Right. He took the zero margin for error mindset of deep sea welding and applied it directly to the retrieval pipelines of artificial neural networks. He is building the safety architecture for the next era of computing.
It's a stunning synthesis of disciplines. He is applying the physical mechanics of survival to the theoretical mathematics of machine learning.
And just to add one more layer of complexity to this section of the CV, there is another publication listed, because why not, right?
Of course.
Alongside the PACAX AI paper on Zenodo, the source material notes he is also responsible for the publication of a book on Óscar Romero, which is available on Amazon.
And this inclusion is profoundly revealing about his underlying motivations. San Óscar Romero was the Archbishop of San Salvador during a period of intense political unrest and violence.
Right, in the late 70s and 80s.
Yes, he was a man who spoke out vehemently against poverty, social injustice, and assassinations. He became the voice of the voiceless, a champion of human rights who was ultimately assassinated, martyred, really while celebrating Mass, specifically because he refused to stop speaking the truth.
On a surface level, you look at a CV and think, how does the historical documentation of a Catholic saint fit next to artificial intelligence architecture, volcano diving, and underwater welding? It feels like a formatting error on the website.
It really does. But if you look at the mechanics of what he is doing, it fits perfectly. It reveals a profound underlying commitment to the preservation of truth.
The preservation of truth. Okay, explain that connection.
Well, let's look at the actions, not the job titles. What is a bathymetric map of Lake Gueja? It is the act of preserving the historical truth of a submerged Maya civilization before it is lost.
Okay.
What is a humpback whale photo ID catalog? It's the act of preserving the biological truth of an ecosystem so it can be protected from industrial harm. What is the PAX AI architecture? It is a mathematical framework designed to preserve factual truth and prevent the degradation of digital information.
And publishing a book on San Óscar Romero is the act of preserving the moral and historical truth of a spiritual legacy, making sure that the truth of his life and his sacrifice is not hallucinated, erased, or distorted by time.
Exactly. He is an archivist. He is an extractor of truth across completely different dimensions: physical, digital, historical, and spiritual. The medium changes: sonar, Python code, underwater cameras, historical texts. But the mission is identical: information retrieval.
Information retrieval. That just ties the whole room together. Which leads us to the final and perhaps the most deeply personal piece of this source material. Because the obvious question you have to ask when looking at the Baires.info CV is, what kind of operating system is running in this person's brain?
Yeah, how does someone do all this?
Right. How does one human mind process so many distinct frameworks? We are talking about the physical language of underwater mapping, the biological language of marine ecosystems, the coding languages required for AI vector databases, and actual spoken languages.
The sources indicate he speaks 3 languages fluently: Spanish, English, and Italian.
Right. And he achieved all of these diverse, highly technical qualifications across all these extreme fields while navigating the world with dyslexia.
And this is where we really need to fundamentally reframe how society views neurodivergence. We need to unpack the cognitive reality of dyslexia because it's the key to understanding this entire document.
Okay, let's do it.
Historically, in standard, rigid educational settings, dyslexia is often diagnosed merely as a deficit, a reading difficulty, a glitch in phonological processing that makes decoding written text laborious.
The traditional narrative is that it's a hurdle to be overcome, a disadvantage you have to fight through just to fit into the normal linear system.
But modern cognitive science, and certainly a life lived with the radial trajectory of JBs, suggests something entirely different. Neurologically, dyslexic brains often exhibit wider spacing between the brain's mini-columns, which are the basic computational units of the cortex.
Okay, so the hardware is actually structured differently.
Yes, and this structural difference can make local, sequential processing like reading individual letters in Word one by one more difficult. But that wider spacing drastically enhances global processing.
Global processing, meaning the ability to see the big picture.
Exactly. Dyslexia frequently correlates with highly advanced spatial reasoning, interconnected problem solving, and the ability to perceive macro patterns that neurotypical brains completely miss.
Okay, wait. Advanced spatial reasoning. Let's connect that back to the CV. That is exactly what you need to navigate a 3-dimensional, zero-visibility underwater environment without suffering vertigo.
Yes.
And that is exactly the cognitive framework required to look at thousands of 2D sonar pings and accurately conceptualize a 3D submerged Maya pyramid in the mud of a lake bed.
Yes, and the macro pattern recognition, the ability to see how disparate systems interact. When you are looking at the architecture of a large language model, you aren't just reading sequential lines of code. You are visualizing a massive, high-dimensional, interconnected network of data flows.
It's all architecture.
Right. A dyslexic mind is often uniquely suited to zoom out and see the entire architecture simultaneously. To conceptualize how the physics of a closed-loop diving rebreather can be mathematically mapped onto the retrieval pipeline of a neural network.
So his dyslexia isn't a hurdle he overcame, despite his success. It might be the very engine of his success. It is the operating system that allowed him to view the world so uniquely.
I think so.
While a neurotypical brain might be highly specialized, satisfied with staying on a linear path, becoming a senior diver, then a master diver, and eventually retiring, his operating system naturally seeks patterns and connections across entirely different domains.
It allowed him to master the languages of diving, coding, scientific research, and 3 spoken languages, not by rote memorization, but by fundamentally understanding their underlying structures and patterns. His resume defies standard categorization because the mind that created it defies standard categorization.
Which brings us to the final element prominently displayed on the CV at Baires.info. It is a quote by Isaac Newton. "What we know is a drop, what we don't know is an ocean."
It is the perfect anchor for this entire document.
It really is.
Think about what we have just discussed. The extreme certifications, the AI papers, the archaeological discoveries, the mastery of the most hostile environments on Earth. Despite all of that, his CV is anchored by a quote about how little we actually know.
It's a statement of profound humility, but also relentless curiosity. If you are listening to this and you've ever felt like your brain works differently than the standard way, if you've struggled in a conventional classroom, or if you feel like your interests are just too scattered, JB's story is incredible proof that different wiring isn't a deficit.
No, at all.
It's a diverse toolkit. It can allow you to navigate the darkness, whether that's the literal darkness of a hydro dam, the toxic darkness of an underwater volcano, or the digital darkness of AI hallucinations, and pull out the truth.
He knows the ocean of the unknown is vast, so he is constantly acquiring new tools, new languages, and new frameworks to explore it. He is never satisfied with the drop he already has.
We have covered a massive journey in this deep dive today. I mean, we started with a guy wielding a torch 100 feet underwater, welding tuna boats for the Calvo Group, and securing hydro dams, surviving Delta P with a zero margin for error mindset.
And then taking that mindset to the wildlife.
Right. We watched him take that industrial, deterministic grit and use it to pull tons of lethal synthetic ghost nets out of the Los Cabanos MPA, saving marine life, while simultaneously building the first biometric photo ID catalog for humpback whales.
We saw him transition from the macro scale of whales to the micro scale of bioluminescent ostracods in Honduras, decoding the chemical light of the ocean.
Then he pivoted to charting the complex bathymetry of Lake Geisha to prove the existence of submerged Maya ruins, and diving into the boiling acidic waters of the Ilopango caldera to extract data from geothermal vents.
And finally, applying the deterministic, closed-loop safety architecture of his physical survival to the digital realm, engineering the PAC AI architecture for zero hallucination in large language models, all while preserving the historical and moral truth of San Óscar Romero.
It is a masterclass in extracting truth from chaos. He builds systems, be it a diving safety protocol, an archaeological sonar map, or an AI validation loop that allow humanity to safely access the unknown.
The cross-pollination of ideas is where true innovation happens. If you only ever study software engineering, you will only ever solve AI problems with software engineering thinking.
Yeah.
But if you study AI with the life or death mindset of a commercial deep-sea diver, you invent a completely new paradigm of safety.
Which leaves us with a lingering thought for everyone listening to mull over. We spend so much time right now in the tech world and in society trying to figure out how to make artificial intelligence act more human. We want it to be more creative, more empathetic, more expansive.
Right.
But looking at an extraordinary life like this, documented so clearly on Baires.info, maybe the real question we should be asking isn't about the AI. Maybe the question is, how can we encourage more humans to break out of their comfortable linear silos and explore the vast, terrifying, and beautiful ocean of the unknown?
It is a question that completely redefines what a career, and honestly, a life, can actually be.
Well said. Thanks for joining us on this deep dive. Stay curious, and we'll see you in the deep end.